What is good, my analysts? Today we're going to be looking at a payload that was recovered from a phishing attempt. I'm going to show you the different steps, the tips and tricks and tools that I use when I'm looking at payloads like this to extract the tactical threat intelligence from them. This is not going to be a full-on malware analysis video. I'm going to just show you the kind of different steps you can go ahead to go through this type of payload to extract the information that you need to then assess whether or not there are further indicators of compromise or other compromised systems on your network. So with that said, let's just jump into it. Right off the bat, you can see that we have a bunch of HTML data, and then we have a base64 command here, and then obviously a bunch of base64 data. So you can use a lot of different tools out there. CyberChef, if you're not familiar, you can just Google it. CyberChef's in there, and you could just do a from base64, drag that over there, and it will do a base64 decode. You can do it all with PowerShell, or you can do the base64 command natively here. So let's go ahead and just get into my Visual Studio thing here, and we're just going to paste the base64 data in there. I'm going to save this as base64.txt. Sounds good. Base64.txt. And then all we're going to do is cat base64.txt, pass that over to the base64 command, dash capital D, will output that to decoded.txt. And let's go ahead and open that up. We don't need to see that anymore. We'll have it just in case. Okay, so what do we see here? Let's see, do we want to do that? Yeah, let's do this too. We'll have them all just nice in a row for you. And show you, I'm going to do this step by step. I have no idea what's on the other side of this, so you're going to see me make mistakes, but I think showing the work is important. Okay, first thing here. This SVG source on load, this is something that you need to be familiar with in cybersecurity. So the threat landscape, especially for phishing in terms of delivery mechanisms, they've been migrating a lot towards HTML smuggling. And one of those methods to do that is SVG smuggling. And that's basically using the SVG image format to pass along packed encoded data and then execute it using as the page is rendered, right? So when the page is rendered, it's going to execute it, and that way you can hide it within this because it all gets run on the fly. And you can run JavaScript in here. So probably this is a bunch of JavaScript in here. Another tip as defenders, if you're not getting comfortable or familiar with the different functions within JavaScript, I highly recommend you do so just because so much of it is moving in here. The /r/n is keyword for return new line, and there's a lot of them, which makes me think that this is just like padding and an obfuscation method. If we get to the bottom, the way the SVG works, we'll see a document, open, document, write, yes, and decode URI component, which means there's probably a lot of URI data in here. And then here we go. Dot replace is just right here. In JavaScript, this just means I'm going to replace that /r/n with nothing. That's it. So we can easily figure out what this is. All we're going to do is, again, we'll copy and paste this data. We'll copy it. We'll create a new file just so we can keep it all. I'll paste this in there. We will save this as, we'll call it stage2.html. Okay, so now we have this. And what do we need to do? We just need to do a replace function. Again, you could use CyberChef for this. So you can go ahead and do a replace. And you could do simple string /r/n, replace it, and you'll get the output. Or you can use the baked in tools. PowerShell is great at this. You could use sed, a bunch of different ways you could do it. With PowerShell, we would just basically say, let's call test equals paste all that data in there. It's going to take a second for it to do it. And then dot replace. Oh, did it again. We'll do wire equals, paste all this in there. Actually, we could probably just grab it from the file. Like I said, I'm going to do this live. So, and then you just do dot replace /r/n. And then just 2 quotes to replace it with nothing. And then, what did I call it? Oh, Dwyer. And now we can see all that sort of data in there. So we can copy and paste all that over. So let's go ahead and do that. We'll do a new text file and paste it in there. Okay, so now we have another HTML file. So we'll call this stage2 decoded.html. All right. And like I said before, this is still, don't be intimidated when you see this kind of stuff because there's clues that you can look into. So this is still HTML data. And then you see all these percent and then numbers. Remember when it said at the bottom here, decode URI, where was that? Yeah, and here. Decode URI component. All this is just URI and encoded data. So there are things on the internet, you just type in URI decode and look, first result, you go like this, you paste it in there and hit decode, and then you'll get the URI decoded data. You can also use PowerShell to do this because it has a built-in component to do a decode, right? So let me open up my PowerShell again. We'll clear all this. And so we have stage, and so we'll call this Dwyer equals get content stage2 decoded. And then you can use one other thing. So we'll call, we'll say, I don't know, Dwyer decoded equals system.net.webutility, spelling, hopefully correctly, and URL decode, and we'll do that on Dwyer. And as long as I didn't mess that up and type something wrong, yep, here you go. And you can see we have it decoded and it's a lot easier to read. So let's go ahead and just copy and paste that over into, oh, where is it? Oh, did I lose it? No, I didn't. Here it is. Sorry, other screen. All right. We'll go ahead and just delete, copy and paste that. Okay, so now this looks a lot easier to deal with. Now we can actually see the HTML data. It looks right off the bat we have these. I'm willing to bet many American dollars that this is base64 data. We could try to concatenate those together because there's 1, 2, 3, 4, 5 of them. And then here is a bunch of JavaScript right off the bat. And oh, you know what else I see? We'll format this to make it look a lot nicer, but look right here. See this variable that is just nonsense? And then you have a bunch of different known commands in here. This is a common obfuscation technique to do a replace. So in a lot of sort of dynamic analysis of code and things like that will look for, unsafe commands. And instead of saying like run, Latin 1 or whatever this was going to be, run console, then actually run X. And I'm going to go through this array here and then find a swap. so that you can in X automatically becomes one of these commands. So this is definitely heavily obfuscated. You can tell right off the bat, and that's probably one of the things that is due. It probably loops through and does a replace on all these kind of things. So let's make this a lot nicer. Yes. So, and then I use a tool called JS Beautify here in VS Code, and it does a nice job of making this a lot easier to use, right? So it's just an extension in VS Code, JS Beautify, and now we can see that this is a lot easier to digest. Okay, taking a look at the JavaScript here, there's a lot going on. You can see that it's heavily obfuscated. Every time you just see a lot of variables being defined as numbers or just random strings. This is probably run through some sort of obfuscation tool, which means there's a lot of probably string replaces and different functions like that. Like I said before, this right here is likely some sort of rip and replace on commands that are going to be used later. There's replace all. So it's probably going to be replacing strings, and it kind of just loops through there. And what else do we have? This is a bunch of stuff we're going to have to figure out. Here's something. This looks like it's something. Anyway, let's quickly kind of take a look at this. Paste. And all we want to do is we'll do dwyer to string. And I'm only doing that just because I don't know if like all the different quote signs in there are going to make it weird. Replace, and I just want to get rid of all the single quotes. And you can, the other thing that's great about the replace function is you can chain these together, and we want to get rid of all the commas with nothing. What else is there? And then we'll get rid of all the spaces. Like it looks to me like there's a space between some of these characters. Let's see what this is. Ah, okay. Yeah. All right. So this UGGCF, if you don't know right off the bat, you could just Google it. But what this is, and I didn't know what this was until I Googled it a bunch of times before, but this is just a ROT13 encrypted or encoded payload. So you can just Google that and you'll get what it is. And there's probably a replace function in there that's going to replace these parentheses with flashes. But this is what keyed in. This is immediately what I'm going to key in on. Crypto-js-min.js, which is a JavaScript way to encrypt and decrypt data, which means there's probably encrypted data in this thing that gets decrypted on the fly. Now, if it gets decrypted on the fly, there's more often than not when you're looking at phishing information, then the key to do the decryption is somewhere in the code. I bet that's the first thing we're going to look right off the bat. We're going to see if we can't find where the key is and see where the decryption function is. So, and like I said before, here we go. So this is right here. This POW function, join together, get rid of the spaces, replace the parentheses with slashes to make it a valid URL. Okay, so it is using the CryptoJS somewhere. So the first thing we want to do is we want to do a find, and I just want to do a find for CryptoJS. And this is probably the decrypt right here. These little red dots on the left-hand side, these are just breakpoints. I'm going to do a breakpoint on all of every reference to CryptoJS. I'm also going to change this Log. I'm just going to put another line in here to breakpoint before the script is finished, just so it doesn't try to detonate anything. Also, okay, the other thing that I noticed is, so like this thing right here, oops, nope, don't rename stuff. It looks like it's referenced in the bottom there. Okay. Another clue. Okay, so like I said before, that looked like base64 data. Here it is basically looping through and taking 1, 4, 2, 3, going through that, adding them together, concatenating them together, and then ATOB, another keyword, ATOB, I'm not exactly sure how ATOB is how I've always said it, is a JavaScript for base64 decode. So it is base64 encoded data. We just need to put them together in the right way. So, okay, so this is immediately what I would do from a plan of attack is start looking. I'm going to start this in a debugger mode because what I want to do is all these kind of like name replace. These are all string replaces to obfuscate what the command is actually doing. Like that, you can just kind of look at this and see that just a bunch of junk in here, and they're just trying to make it as difficult for a human to read as possible. But one of the things in Node.js that we can do is we'll just start this in a debugger with these different breakpoints, and then we'll be able to evaluate the values and all of these kind of commands to basically figure out what all of those mean. And the first thing I want to do is I want to look for where, because I didn't see it anywhere else. CryptoJS. Oh, breakpoint down here. But we know that this one's encrypt, so because -enc or CryptoJS dot enc is encryption, which means it's just going to put something crazy on the output. Where we're going to look for the word decrypt, right, is probably right here, right? Because just knowing, if you Google like how to decrypt with CryptoJS, it's going to have code that looks like this. But I'm going to show you the steps. Like if I didn't actually know that, we're just going to look for where is the line for decrypt and take it from there. And I bet we'll be able to find out a key, hopefully, and then we'll just do a decryption to see what is being decrypted, because there's obviously more data in here that we can see that we need to pull out, and it's probably in this base64. Now that makes sense, right? Light bulb. They put together all the base64 data here, pass that to the decryption or encrypt it somewhere in this. We'll have to go through it and then decrypt it on the fly. Okay, so let's start with that plan of attack first and go from there. We'll see where we get from here. Okay, so the next thing that we need to do is start our debugger, and so we can get to these lines. So let's go ahead and just start debugging, let it go. A Chrome window is going to open up in the back. Now, do you remember why I said we want to do this in a debugger so we can kind of keep track of things? One of the things that just popped up immediately when I was like, oh, we're going to be looking for the key is if we see this right up above here, this value right here. So I can right click on that and evaluate in the debug console, test pass, right? So that's an obvious that this is right here. This means this X. Yeah, because this is 256, yeah, encoded to make a key, right? So if I go to evaluate X in the debug console, that's our key. Willing to bet a lot of money on that. Yeah, you can see it right down here. CryptoJS. As we'll step through this, we'll get there, but it calls key right here. I bet that this is the key. I'm almost sure of it, that this is the key, right? So this is why I'm saying, like, you don't need to be a super, we're going to go through this. That's a very good strategy when you're looking for payloads that render dynamically in websites, especially the way that I've seen a lot of these. If they're referencing CryptoJS and they're the data is encrypted, most of the time you can get the decryption key right from the code itself. You just got to know where to look. And the first thing I ever do is set breakpoints every time CryptoJS is mentioned and go from there. Look for the decrypt word. And as we step through this, we'll be able to find the word decrypt, right? Because what we'll be able to do is you see this, we evaluate that, right click, evaluate and debug, and substring, right? So this is actually just substring. And if you remember before, when you see something like this, and I bet the word decrypt is in here, so, yeah, right here. So decrypt is in there. So eventually we're going to find a line that's going to be CryptoJS calling decrypt. And in that line, we'll find a reference to the key. And all we can do, and then I'll show you what we're going to do. I'll show you what we can do, like without having to know anything about CryptoJS. I'll show you exactly what we're going to do to take care of this. So let's go down here. And we're just going to step over this. What I want to kind of do, it looks like activation function loops through here. And I'm just going to add this to my watch list right over here. So we'll be able to see this go and get populated. Yeah. So you can see activation function is populating over here, and it's just being every time that ran through, it just added 1, 4, 2, 3 together in that order. So as long as we remember that, we can do that pretty easily on our own. We don't need to know that. So it looks like then did a base 64, which means all of this is probably going to be, yeah, see, this is all gobbledygook because it's just more junk, right? Let's go ahead and see what this means. That's encrypt, right? So 0x185 is encrypt. So we basically know that these three are encrypt, right? Which means that we can't really grab anything from there. Let's see what this one is. Decrypt. All right. See, you see how that goes? This is where we want to be, right? So I'm going to basically actually, we just leave this in debugging because that means that this function right here does a decryption using the key that we know. So we can basically take this code and just reuse it, supply the key, and decrypt whatever is in there to see what the second stage payload. So we're going to do that now. Okay, so the first thing that I want to do is we are going to replicate this activation function, which means we need to combine those classes from the HTML data in order 1432. We're just gonna, okay, so we're gonna do that just by copying and pasting them into a new file. Why I'm just gonna reuse the names because what I want to do is I'm gonna show you that we can just copy and paste all of this over there and reuse it. So we have 1423. So we can say activation function equals part 1 plus part 4 plus part 2 plus part 3. And if that worked, then we won't get an error when we do this. So, because if we messed up, it'll say this isn't valid. Oh, the other thing I want to make sure I copy that because we definitely want to know that. So let me say, let's go ahead and save this. I'm going to stop debugging the other one, even though we're going to go back. Like we are gonna to go back into it in debug mode because we're gonna have to go and grab and find out all the different strings. But this is just to make sure that that we want. So we're going to run it with Node.js. We got no errors, which is great. Okay. So now that that is doing it, we're going to go back to here. We have a couple more. So all we're going to do is just copy and paste this over and copy it over. The only thing we need to do left is put this, is we want to make sure we have our key defined. So that was copied over. The only thing is we don't know. If we tried to run this right now, we would get a bunch of like string errors for what these all mean. So we have to go back in here, go back into debug mode on the first one. I'm going to step over that. And basically all I'm going to do now is make note of, we already know this is encrypt. So what this command would look like over here with the replace is we go over here. This is actually CryptoJS encode Latin 1 parse, because those are valid commands. That. So you see how I did that? It's basically just like a find and replace. Because all of these are being like evaluated as strings by like looping through there. We know that this is in code. Let me evaluate that in the debug console, Latin 1. And then I bet this is parse, evaluate in debug console, parse, right? So that this one becomes crypto.js.encode.latin1.parse. And we can get rid of this. And rinse and repeat. Oh, if I spelled it right, rinse and repeat, right? I'm just going to continue to go that. I'm going to walk through this. I'm going to show you what it looks like. And when you come back, it'll be formatted, and I'll just quickly, instead of making you watch me do this, it'll be a lot better. Okay, so I went through and I did the kind of string replaces over here. So remember, it kind of looked like this with all these references to a function that would just replace it with a string. I went back over to here and replaced those out to just the standard command. So we didn't need to copy and paste any of those other obfuscation functions over. We just put the actual strings in there to make the actual command. The other thing I did is, I forgot to do this before, but I added CryptoJS to our program here. And we can test this. We'll just make sure that there's got no errors or something like that. So what is this called? Dewire.js. We'll run that. We got our command. Great. Love that for us. We'll go ahead and comment that out. Now, the next thing we have to do, now you can just Google this, but if we kind of just took a look at, this is technically decrypted, right? This is the decrypted information. But if we look at this, what did I do? Console.log. If we took a look at this and just let her rip, you'll see that it's not going to be human readable. What you're going to do is get basically an array of words, right? So what we need to do to convert that into something usable for us, we need to do one more CryptoJS command. And you can just Google this. If you got to this part on your own, you can kind of just Google, well, how do I make CryptoJS output human readable? And this is what you're going to get. So the only thing we have to take from our command here is, remember that it was encrypted with Latin 1. So we want to make sure that we use Latin 1 for this. And then we can do console.log for decrypted. And that should be it. So as long as I didn't mess anything up, we should be able to see this. Now I'm going to run this. And yeah, here we go. So this was an encrypted on click, run this final URL. I don't want to scroll up because I'm pretty sure this was a targeted phishing. And I don't want to show the company or the person that got this. But so this was the encrypted information. So if we go back to here, what we would see is that we could kill all these breakpoints, but what I'm imagining is it would decrypt and then on the fly, this document would be opened, and then the second encrypted document would then be put at the end here. So we could like step through most of this. I'm gonna kill all my breakpoints, and you'll see there's probably an initial page, and then on click, it would load the encrypted one on the fly, which would be something else. And knowing what I got from the phishing information was credential harvesting. So yeah, I took a look at this, and as I stepped through, I did see that there was some targeted information in there in terms of a particular organization. Don't want to show that on the screen. So, but I went through the rest of it. There was nothing additional in there other than a highly obfuscated sort of page that rendered, and then when you clicked, then you would get the second stage of that encrypted data, and it was loaded on the fly. But you could go through this if you really wanted to get comfortable with it, but it would take you a long time. But basically, this thing is just looping through all of this junk to do keyword replaces to render a web page that had a lure that says you have a new voicemail. As soon as you click on the voicemail, then you get the encrypted part, which then is the credential harvesting piece. It loads a Office 365 page to try to grab your credentials. So the that's kind of it, right? Like I said before, it's like you don't need to spend the hours and hours looping through every one of these lines. When you see that CryptoJS, it's an immediate thing to key in on and take the 2 minutes or whatever that took us to kind of find the decrypt keyword and then work your way back. And usually you can find the key in there to help you go forward. And anything that's encrypted, especially with phishing attempts, is usually the juicy stuff that really can help you in your analysis or an assessment to see if there's any other indicators of compromise to go forward. So stay tuned. We're going to be doing a lot more of these. Until then, happy hunting.